In this lesson, we will clearly understand bond dissociation energy and average bond enthalpy, and then use them to estimate the heat of a reaction. We will keep this at a CBSE and NIOS friendly level. First, the definitions. Bond dissociation energy, D0, is the energy needed to break one specific bond in 1 mole of a gaseous molecule into gaseous atoms. Average bond enthalpy is an average over many molecules for the same bond type, like a carbon-hydrogen bond, all in the gas phase. The first is molecule-specific and very precise. The second is an average and more convenient when exact data are unavailable. Let's visualize bond dissociation energy using hydrogen chloride. We draw hydrogen-chlorine with a single bond. To dissociate, we must supply energy, so the atoms separate to infinity in the gas phase. That required input is D0 for the hydrogen-chlorine bond. What about average bond enthalpy? Think of the carbon-hydrogen bond appearing in different molecules. Each C-H bond can be slightly stronger or weaker depending on its environment. The tabulated value is the average over many such molecules, for example, about 414 kilojoules per mole for a carbon-hydrogen bond. To estimate the enthalpy change of a reaction, use the standard approximation. Delta H of reaction is the sum of energies of bonds broken minus the sum of energies of bonds formed. Bonds broken cost energy positive. Bonds formed release energy negative contribution in the formula. Now, the worked example, carefully and correctly. Calculate delta H for methane plus chlorine making chloromethane and hydrogen chloride using average bond enthalpies. We break 1 carbon-hydrogen bond and 1 chlorine-chlorine bond. We form 1 carbon-chlorine bond and 1 hydrogen-chlorine bond. Let's list bonds broken and formed. Then we compute the sums and subtract. Finally, we report delta H is negative 112 kilojoules per mole exothermic. Quick recap. Bond dissociation energy D0 is molecule-specific and very precise. Average bond enthalpy is an average over many molecules, convenient but less precise. Use delta H of reaction approximately equal to sum of bonds broken minus sum of bonds formed. And remember the sign convention. Breaking is positive, forming is negative in the subtraction. Visually, keep this picture in mind. Breaking a bond costs energy. Forming a bond releases energy. Keep practicing with tables of average bond enthalpies. And use precise D0 values when available.